Welcome to Maths with EJD. In this video, I'll be talking about cooperative game theory. All right. First of all, let's delve into the concept itself, cooperative game theory. Now, looking at other types of games we have checked, we have seen the usefulness of cooperation, how cooperation can evolve in a game over if the game is played repetitively, and if all the players involved know that there is going to be the possibility of having to play the game again. So it leads to some kind of cooperation. So let's understand the cooperative game theory itself in depth. So, cooperative cooperative game theory focuses on how players can collaborate to achieve better outcomes than acting alone. So in this case, you have players forming coalitions. Players form coalitions, share resources, and distribute rewards based on contributions. I mean, this gives a very good example of you know, in some cases, in some places we have cooperatives where where all the participants they contribute their funds, and then they can get loans proportional to the funds they put in. They can also get some other benefits, proportional to the kind of investment they have in the cooperative. So let's move on to look at the key concepts in cooperative game theory. Key concepts. So first of all, we have the idea of coalition. So a coalition is actually a group of players working together for mutual benefits. So, I mean, we get to hear a lot about political coalitions in different countries where all the opposition parties come together to face the big party. Then we also have the idea of a Shapley, sharp, I think it's better pronounced Shapley. We have the Shapley value, which is a method for fairly distributing payoffs, a method for fairly distributing payoffs based on each player's contribution. I mean, this is to guarantee fairness in the cooperation. Okay. Then we also have the idea of core. So every cooperative game has its core, and a core is actually a distribution where no player wants to leave the coalition. So, I mean, some coalitions fall apart and some players can leave. But if you can get the core of the coalition, then nobody wants to leave. Then we have the nucleolus, the nucleolus. So, and this is actually the optimal distribution. This is the optimal distribution that minimizes dissatisfaction. Dissatisfaction. Okay. Then let's look properly into the concepts of cooperative. I mean, we've seen this previously, right? We just want to refresh our memories about this in case you've not seen the previous video where we talked about this. So let's talk about cooperative versus non-cooperative games. I mean, it's quite obvious, right? That cooperative games, hmm, cooperative games, in cooperative games, right, you have players form binding agreements, players form binding agreements to maximize collective rewards, e.g., like a joint business venture. So you have joint business ventures as good examples of cooperative games. And I've also given the example of cooperatives in some settings. Then we also have non-cooperative games on the other hand, which is just the opposite of that. Non-cooperative games. Players act independently. Players act independently to maximize individual payoffs. To maximize individual payoffs. So here, nobody's interested in cooperation. So, e.g., we have market competition, where brands are pitched against themselves and they don't ever form any kind of coalition. All right, we can also see some real world applications of cooperative games. Real world applications. Real world applications of cooperative games. Of course, I mean, goes without saying that business alliances are very good examples of that. Business alliances where you have, okay, sorry, I had intended to change colors at this point. So, yeah, I want to go this now. Real world applications. So, we talk about business alliances, for instance, business alliances. Here, companies collaborate. Companies collaborate for shared benefits. Then we also have political coalitions, which I've talked about previously. Political coalitions, like you have political parties joining forces, political parties join forces to form a government. There are some situations where the in an election, the winning party does not win with a significant margin. So as a result of that, they have to share power with other parties. So that's a good example. Then you also have international trade. International trade. So these days we have, you know, many organizations. BRICS is coming up. Then you also have is it G7? You have all these kind of countries, OECD and all of those. So countries cooperate. Countries cooperate on trade and environmental policies. Okay. Of course, in all, we need to know that let's talk about a kind of conclusion now that theory, cooperative game theory offers insights offers insights into how cooperation can lead to optimal outcomes in economics, in business, and politics. Okay. Um, so this is the end of this video, but in the next three videos, I'll be talking about the core of a cooperative game. I mean, we are going to have some kind of calculations of the kind of things that go on there. Then we'll talk about the Shapley value and of course the bargaining solutions of a in cooperative game. So watch out for this. You want if you are not signed up to this channel, you want to subscribe right away and hit the notification bell. And of course, you want to comment to let me know if all these things are really useful for you. And of course, if you want me to teach a topic or solve a problem and you want to like and share so that more people can have access to this great learning, I believe. So till then, keep playing the game of life with wisdom. Bye.